All right, now let's do example 2 here. And now we're going to mix it up a little bit because we're not using the inverse property, right? The composite property for functions and their inverse. We're going to mix it up a little bit. So now what we're going to do is we're going to find the exact answers by using the definitions of these, okay? So, in order to solve, let's do A first, right? So think about this. Okay, we're taking arc cosine of 2/3. So we're trying to find the angle, right, whose cosine is 2/3. Okay, so let's do it this way, right? So let's start with the inside and work our way out. So the first thing I would do is draw this. Now this is 2/3. It's positive. Cosine is positive in the first quadrant. So let's draw our triangle. Okay, so here's our right triangle. Here's theta. First thing we're going to do is deal with this, right? So we're looking for the cosine of what angle is 2/3. So cosine of this theta is what? Adjacent over hypotenuse. So this is going to be 2, this is going to be 3. Okay? Okay. Now, let's find what this is. Okay? So this missing side here is what? Well, let's use the Pythagorean theorem. So let's do that. X. So we know that 2 squared plus x squared equals 3 squared. And so we know x squared equals 3 squared minus 2 squared, which equals 9 minus 4, which equals 5. So x equals the square root of 5. Okay? And since we're in the first quadrant, x has to be positive. So this is going to be square root of 5. Okay, now, notice how I didn't even try to find what this angle is, because we don't care. Okay? We just know it's theta. Okay? Now, we want the tangent of theta. Right? So what's tangent of theta? Well, we just figured out what this side is. So it's tangent of theta is what? Is opposite over adjacent. And so this is going to be the square root of 5 over 2. We're done. Okay? Let's do the next one. Let's start with this inside one, right? So again, we're looking for theta, right? This is an angle. Okay? Okay, we're not going to solve theta directly, right? But we're going to use this now. Use this to help us. So now it says arc sine. So we're looking for, okay, the sine of what angle is going to be negative 3/4. So sine is negative. Now sine is only negative in the fourth, right? The fourth quadrant and the third quadrant. But we're dealing with, again, the domain, right? Okay, so the domain or the range of this thing is going to be from negative pi over 2 to pi over 2. Okay, so we're going to be in the fourth quadrant. Okay, so let's draw a reference triangle here in the fourth quadrant, right? So there's our fourth quadrant. Here's our theta. Now, sine of this is what? It's 3 opposite over hypotenuse. So this is going to be 4. This is going to be 3, and this has to be negative, right? Now, let's solve for the missing side. So in this case here, it's going to be x squared plus 3 squared equals 4 squared. So x squared is going to equal 4 squared minus 3 squared, which is going to equal 16 minus 9, which equals 7. Okay, oops. Hold on a second. Did I do this right? Hold on. Sine opposite over hypotenuse. Yeah. Oh, you know what? I knew something wasn't looking right. Okay, so the way I did this, okay, anyway, I'm just going to finish it up. So the way I did this is -7. So this is correct. So this is going to be square root of 7. Okay, and now, again, I'm not solving for this specifically, right? I'm just using my right triangle because I need cosine of theta. Well, now that I got all 4, cosine is going to be opposite or adjacent over hypotenuse. So this is going to be the square root of 7 over 4. Now, I made a mistake because I wrote down the problem wrong. So let me redo this, and this should be not -3/4, but it should be -3 over 5. Okay? So, oops, let me redo this here. Okay, so this is going to be 5, and what's going to happen is this is going to turn out to be 4 because this is one of those special triangles, 3, 4, 5 triangle. And so what's going to happen is this is going to be equal to 5 over 4. Okay. And it's positive because it's in the 4th quadrant. But let's go through the process to verify that, right? So again, if I do the Pythagorean theorem, so I go x squared plus 3 squared equals 5 squared. And so I get x squared equals 5 squared minus 3 squared, which is then going to be 25 minus 9, which equals 16, and then of course x equals 4, okay, by taking the square root of both sides. Okay, and so there you go, got an extra example in there for free. All right, have a great day, take care.